Chapter 5 review. Remember the retake is at 7:30. This one says find VT. We have to kind of look at the information here and realize what kind of segment YZ is. And because these are midpoints, that's a midpoint, right? Let's get this marker working. That's a midpoint, and that's a midpoint. Then we know that segment's a mid-segment. And we learned that mid-segments are half the length that they of the side of the triangle that they are parallel to. Okay, so YZ is equal to 1/2 TV. Or we can think 2 YZs could equal 1 TV. If I multiply this by 2, I would get this equation here. I like using this one. Most people like this one because you're avoiding fractions. So I'm going to say 2 YZs, so 2x plus 2's should equal 1 TV, which is 3x minus 3. So we get 2x plus 4 equals 3x minus 3. Subtract 2x, add 3, x is 7. Okay, now be careful, they don't want x, they want VT. Okay, so come over here to VT, and you get 7 times 3 is 21, minus 3 is 18. So there's my answer. You saw this question on a quiz earlier in the chapter. This question is the same idea. They give me the information here to show that NO is a mid-segment. They're saying actually all of these NO, MO, and NM are all mid-segments. They tell me NO is 22. So that segment right there is 22. And JK is 4x plus 24. So what we need to do is say that, how does NO relate to JK? Well, we know that either 1 NO is half a JK, or 2 NOs is 1 JK. I like 2 NOs because 44 will then equal 4x plus 24. Subtract 24 from both sides, get 20 is equal to 4x. Divided by 4, x ends up being 5. Again, same type of question, but now instead of giving you the notation they gave you in the last one, they're providing the notation and an explanation here. They're saying E, D, and H are all midpoints, so we know that's congruent to that's congruent to that, and this is congruent to that. So all these interior segments are mid-segments. They're saying U of V is 74, so that's 74. TV is 96, and then HD right here is 74. Okay, I want you to find TU, which is that segment there. Well, all you gotta do is, because that is parallel to HD, so we know HD is equal to half of TU, or 2 HDs should equal 1 TU. So if HD is 74, 2 of them should equal what we're looking for. So 74 times 2 is 128. This is the exact same idea. It's a mid-segment, okay? So we're going to say 2x plus 2's equal 24. I'll go ahead and let you solve that one on your own. Okay. Here we have to use the idea of angle bisectors. Okay. They're talking about, like they say, find Y, ST, and TU. Okay. We know that if we're looking, use a different color here. If we're using this angle here, and because of this notation right here and here, we know that VT is an angle bisector. If VT is an angle bisector, then a theorem that we learned was that any point on VT is equidistant from this ray here and that ray. So that point there is equidistant from that ray and that ray. So that distance there would be the same as that distance there. That point there would be the same distance from this ray as it is from this bottom ray. Okay? So the point that they're interested here on that angle bisector is T. So we should know that that distance from T to this ray and from T to the bottom ray VU, those two distances should be the same. So 4y should equal 2y plus 6. 2y equals 6, y is equal to 3. If y is equal to 3, then ST is 2 times 3 plus 6, which is 12. And that's TU. TU is 12. And then ST is 4 times 3, which is 12 as well. Okay, so the fact that those two things end up being the same reminds me that I've done my math right, or shows me I've done my math right. This is more of a vocabulary question, and usually I don't go over the vocabulary questions with you, but I will this one. It asks me to identify in an equilateral triangle the point E, what it's called. And it also tells me that X, Y, and Z are all midpoints. So if I know that that's a midpoint, and now it's the equilateral, so the original segment, each side of the triangle is the same, so when I cut those three sides up, the 6 individual parts that I get, the 6 individual parts, they should all be the same as well. Okay, so all those segments there are the same. That makes each one of these interior lines, that makes that line there and that line there a median. So if that's a median, E is a centroid. Okay. Now, looking at this stuff, we're also showing that we're going from this vertex to this side over here, and we're perpendicular. So that segment, by definition, that would be an altitude. Same thing's happening here. That's an altitude. Okay? So where the altitudes meet, and the third one's an altitude as well, but where the altitudes meet is the orthocenter. Okay? And I keep looking at this, and I keep investigating it. We know that this segment is a perpendicular bisector of this segment. Because y is a midpoint, and we're perpendicular. Okay, so kind of highlighting here, that segment there is a perpendicular bisector. We also know that that's a midpoint, that's perpendicular, so this must be a perpendicular bisector. The perpendicular bisectors meet at a circumcenter. And the last thing we know is that in any equilateral or isosceles triangle, from the vertex angle, if you go from the vertex angle perpendicular to the base, you bisect the base, then this line here, from a corollary that we learned earlier in the year, that line bisects that angle. And that's for an isosceles triangle. Okay? But what's neat about an equilateral triangle is that all these angles are the same. So this line here is going to do the same thing for that angle there. And this line here does the same thing for that angle. So all these red lines are also angle bisectors. And the angle bisectors meet at the incenter, which is right there. Okay? So some of us got this wrong because we looked at this and said centroid. That's the only one. And you're right that it is a centroid, but the question says identify, says choose all that apply, identify what E is called. Okay, in this case, E is all those things. This is a centroid question because all these segments are medians, so they're showing me that that point right there is a centroid. And I'm focusing on A, R, G, those 3 points. So I'm going to redraw my picture. There's R, A is about right there, and G is over here. So that's my picture. They tell me what RA is. I'm just going to highlight what they're telling me. RA is that. And AG is the other thing that they are giving me, which is that. Okay? We need to relate those two distances. Okay? Well, that's a part of a median compared to a part of a median. We learned that when I compare a part of a median to a part of a median, the part that goes from the vertex to the centroid, so this blue part, that is the longest one. AR is bigger than AG. We want to make these two things equal. Okay, we learned that this segment here, AR, is 2 times as big as AG. So 2 AGs will make 1 AR. Now that I know that, I can go 10x minus 2 is AR, and then 2 times 3x plus 3 is AG. 10x minus 2 is equal to 6x plus 6. 4x then is going to equal 8. X is 2. If x is 2, I'm going to plug things back in to find AG. So I'm going to get 6 plus 3 is 9. And then we'll plug things back in to get AR, which is going to be 20 minus 2 is 18. So comparing those two things, I see that one is twice as big as the other. And then once I know what RG is the entire segment, so it's going to be 27. And if you remember from what we've learned about centroids, if I compare a part to the entire thing, I should get 1/3 and 2/3 ratios. Well, if I compare 18, a part of my median, to the whole thing, that reduces to 2/3. If I compare 9 to the whole thing, that reduces to 1/3. So it's showing me that this is 1/3 the entire median, and this is 2/3 the entire median. Alright, and again, 1/3 and 2/3, they compare to being halves or double one another, in whatever order you look at the relationship. This one actually uses, I believe, that 1/3, 2/3 idea. They're talking about SW and SF. I'm just going to redraw my picture, dealing with just those segments. So there's F, there's W, there's S. They're giving me SW, which let me start over, or at least erase this. Okay, the parts they give me SW, which is going to be that part. And they also give me SF, which is that part. Okay, now those are, or when we compare these, we're comparing a entire median, the blue part, to a part of the median, the green part. Now the green part goes from a vertex to the centroid. So that, and that distance is always 2/3 of the entire median. So when I make SW and SF, I try to make them equal. Okay, I look at how this green segment compares to the blue segment. The green segment is 2/3 of the blue one. So SW is 2/3 the blue segment, which is SF. Now SW was 3x plus 3. I'm going to have SF as 6x minus 6. Some of you probably like the algebra of multiplying everything by 3. That's going to give me 9x plus 9 is equal to 2 times 6x minus 6. Distribute my 2, you get 12x minus 12, and 9x plus 9. Subtract 9x from both sides, I get 3x. I'll add 12 to both sides and get 21. So here I get x to be 7. Now if x is 7, they want SW and SF. Well, SW would be 21 plus 3, which is 24. And SF would be 42 minus 6, which ends up being 36. Gotta check to see if I've done this right. 24 compared to 36 reduces to 2/3, the relationship that we knew had to exist. This question is playing off the idea of knowing what medians are. It says I, G, H, J are medians, so if they're medians, that and that have to be midpoints. They're telling me that FG is 3x minus 10. They tell me that GH is negative 9x plus 38. And they tell me FJ is x plus 3. Okay. Now in solving this, I have to look at these things and see how they're related. I know that that segment there and that segment there are the same because that's a midpoint. So I'm going to say 3x minus 10 is equal to negative 9x plus 38. 12x minus 10 is equal to 38. 12x is equal to 48. X then is 4. Okay? Now it asks me to find JI. Well, I don't have an expression for JI. I don't know what that is. But I do know an expression for FJ. FJ is x plus 3, so FJ is going to be 7. Well, if that's a midpoint, that distance there also has to be 7. So JI or IJ is 7. This is based on the criteria provided in the picture. Identify what point X is called. I have to look at the information. Okay, I'm looking at X. I'm going to highlight that for us. Okay, now I'm going to look at the segments that come together to make X. That segment there and that segment there. Those make X. Just find what those segments are. Well, I know that that's a midpoint because of that and that. And I also know that this is a midpoint because that's a 7 and that's a 7. Okay, so those segments are congruent. So segments that start at vertices and go to midpoints of the opposite side, those segments are medians. So those two things are medians. So medians intersect at centroids. It's just another vocabulary question. Here's another vocabulary question. What is M? Well, let's look at what kind of segments make up M. We're looking at that segment there, and we're looking at that segment there. A couple pieces of criteria for those segments is that they're perpendicular, and if that's 7 and that's 7, that must be a midpoint. So that makes that segment there, that blue segment, this one here, a perpendicular bisector. Come over here, perpendicular, and that's a midpoint. So that's a perpendicular bisector. Perpendicular bisectors intersect at the circumcenter. Okay? Uh, 13, what is M? Okay, again, highlight M. So I guess the lines that are concurrent to make M. And all we learn about those lines is that we are perpendicular to the other side. We go from a vertex perpendicular to the other side. So that line there, each of those red lines, is an altitude. By definition, any line that goes from a vertex perpendicular to the side, or the line containing the opposite side, is an altitude. Altitudes intersect at the ortho center. (14) is BK a median or an altitude? BK is that distance right there. It is neither. Some of you had AB. AB here, for this particular problem, AB is an altitude. It goes from a vertex perpendicular to the other side. So AB would be an altitude. CA is also an altitude. It goes from a vertex perpendicular to the other, or the opposite side. If I look at BQ, BQ here is just a median because we go to a midpoint over here. And AP would also be a median because we go to a midpoint over there. Okay, so you may have had one of those 4 or 5 different lines, so trying to explain what each one of those in there is, I think would be helpful. Here it says name the centroid. Okay, centroids are found by medians, intersection of medians. So that is a median. You go from a vertex to a midpoint. That is a median, or vertex to a midpoint. So V is going to be the point that we're looking for. Some people miss this because they're putting lowercase v. Remember, points are capital letters. MathXL is going to abide by that rule. W is intersection of those 2 lines, one of them being a median. This line right here that one is a median, but this segment here, that's a mid-segment. And we don't have a point. We never talked about when a mid-segment and a median intersect one another. Determine the relationship between the lengths of the sides. So going through this, it's probably useful to know what these missing angles are. That's 40. This is going to be, what, 40? And this one, 1555, is 105. So this has to be 75. Okay. So those are the missing angles. Now, if I got AE and EB, AE and EB, AE being that segment, and EB being that segment. Now, they're both in the same triangle, and all I got to do is determine whether they're less than, greater than, equal to, or congruent. AE is across from 30, and BE is across from 110. So 110 is bigger, so BE is going to have to be bigger than AE. Okay, 110 is bigger than 30, so the side across from 110 is bigger than the side across from 30. So BE is bigger than AE. Now, they have it in this order. We want to compare AE to EB. So AE is actually less than BE. So we're going to go less than. They want CE compared to CD. So CE is that segment there. CD is that one. We know that was 75. So 75 is bigger, okay, because 75 is across from that side, than 55. So 75 is bigger than 55. So the side across from 75, which is CE, must be bigger than the side that's across from 55, which is CD. So CE is bigger than CD. The last one they're asking for here is BC and EC. BC and EC. Well, we know that's 40. Across from 40, across from 40. There's no difference in the angles, so there's no difference in the side. Those two have to be congruent. Okay, if we look at, if I complete this problem, oh, it's not showing. It should congruent because we're talking about segments now. Okay, so their segments are congruent. If it just said BC and EC, now we're talking about distances because there's no segment above, then those would be equal. But BC, the segment BC, is congruent to the segment EC. Just make sure that you know your notation and understand the difference. This question here, reading through this, guy gets the ball at third base, and he has a choice to either throw it to second base to get an out, or throw it to first base to get an out. And we have to decide which of those distances is shorter. This distance here to second base is shorter than the distance to first base because the blue distance is across from an angle of 45, and this distance here, this red distance, is across from an angle of 90. Okay, so second base is what we need to choose. That's the correct base. And then the reason is because the side opposite a smaller angle, which this side is opposite 45, is always a shorter length than the side opposite a larger angle. So the blue, because it's across from a smaller angle, is a shorter throw than the red, because the red is across from a larger angle. In order to do this correctly, you need a picture. Okay, we're talking about P, Q, and R. We know that those three angles are 9n plus 29. We've got 10n plus 2, and then 93 minus 5n. The thing that we know about those three angles is that they should be adding up to 180. So we get 9n plus 29 plus 10n plus 2 plus 93 minus 5n should equal 180. Now I'm going to go ahead and combine like terms. I got, what, 19n minus 5n would be 14n. I got 29, there's 31. 31 plus 93 would be 124. Should equal 180. Subtract 124 from both sides, I get 14n is equal to 180 minus 124 is 56. And then divide 56 by 14, and you get 4. So n is 4. Now if n is 4, that makes this angle here 42. It makes this angle here 73. It makes this angle here 36 plus 29. It makes that 65. There you go, 65. So now if I know those angles, I should know the order of the sides. 73 is the biggest angle, so that's the biggest side. And this is the smallest angle, so that's the smallest side across from it. And across the middle angle would be the middle side. Okay, now they want longest to shortest. Longest to shortest. So we're going to go RP, and then we go to QR, and then we go to PQ. Here it says use triangle ABC, which side is the longest. Okay. We've got AC, BC, and AB. So we're looking at these three sides. Look at this 61 degrees. That tells me that this is 119 degrees, and that these two angles here are going to add up to 61. I don't necessarily need to know what they are, but I do know, because this is 4, that this angle here is bigger than angle C. But it's asking, which of these three is the largest side. Well, 119 is going to be the biggest angle in there. You can't have an angle in this triangle that's bigger than 119. Okay, so across from that is BC, so BC is going to be the longest side. Can these two triangles, or these three segments, create a triangle? You take the smallest two, add them together, and you get 9. And you compare 9 to the last side, which is 12. This number of 9 has to be bigger than 12 for you to be able to create a triangle. So our answer is no, because 4 plus 5 is less than 12, and that contradicts the triangle inequality theorem. List the angles of the triangle in order from smallest to largest. So we've got DEF, so there's D, there's E, there's F. FD is 5, ED is 6, and EF is 4. So across from 6 would be the biggest angle. Across from 4 would be the smallest one. And then this would be the middle one. And it says smallest to largest, so D, E, F. Since the triangle has side lengths of 10 and 2, what can you say about the length of the third side? Remember, if we have two sides, we don't know if they are the smallest or the largest. Okay, so basically what we're saying here is that these two could be the smallest two sides. So when we add those together, they would have to be bigger than 12. Okay, and this could be the biggest side, and this could be the smallest side. So we can think, okay, what do I add to that one so that total is bigger than 10, and that would be 8. Okay, so that's the kind of the philosophy or the thought behind this concept. But what we do to find this third side is simply take those two numbers, and the upper number is going to be found by adding the two values, and the lower number is found by subtracting the two values. So our third side is between those two values. Okay, so x is, if we read this, x is longer than 8. That's what that means. X is bigger than 8 and shorter than 12. So if I read that there, x is less than 12, shorter than 12. This particular question, we're going to look at using a triangle inequality theorem, and we know that looking at this side, that's congruent to that side, and this is congruent to itself. Now 28 is smaller than 54. Okay, so we're using side inequality here. We know something about all three sides. 28 is smaller, so opposite 28, which is x plus 20, that needs to be smaller than what is across from 54, which is 41. Subtract 20 from both sides, you get x to be less than 21. And that's fine, that's true, but there are values that are less than 21 that would provide me a problem here. If I plug x to be, negative 100 is less than 21. Plug negative 100 in here, you get a negative 80-degree angle, and you can't have that. So we learned that we must force that thing, because it's an angle, it has to be positive. It has to be greater than 0. So subtract 20 from both sides, and x has to be greater than negative 20. So those two things together are going to say negative 20 is less than x, which is less than 21. So that's telling me x has to be between negative 20 and 21. Numbers outside that range will either provide me an angle here that is bigger than 41, which that would contradict the side inequality, or it would give me a negative angle, which would contradict everything we know about angles at this moment. Right inequality about the side lengths. Okay, we've got side, angle, side, side, angle, side. We know that that angle is smaller than that one, so across from 45, QR should be smaller than what's across from 60, which is DE. So QR is smaller than DE. Same idea here. Trying to use, we got a side congruent to a side, another side congruent to another side. So far we've got a side and a side. But right now in this one we got side, angle, side. There, that angle is included. But in this one, we would need to know that angle there. We need the included angle, because it's side, angle, angel's got to be in the middle. Okay, 60 is not in the middle. So I can't say anything about these two terms. I have absolutely no clue which sides are smaller or equal or whatever, because I don't have the right comparison of parts to make a conclusion. So there's no conclusion there. Says, which position is the tip of the robotic arm closer to the base? Use a hinge theorem to justify your answer. Because these arms are the same, that side and that side are the same length. That side and that side are the same length. Now we know that angle is bigger compared to that angle, so you got side, angle, side here. So this across from 56 should be the bigger side, and that's going to be the smaller side. Okay. It says, when the labeled angle measure of the robotic arm changes from 56 to 48, does the length of AB change? AB being that. Does that change? No. The robotic arm is a fixed distance. It cannot change. It cannot shrink or grow. Same thing for BC. It's a fixed distance. It cannot grow. So the included angle measurement of 56 degrees is larger or greater than 48. That's obvious. By the hinge theorem, okay, which is, we talked about that also being the side angle side theorem, the robotic arm is farther from the base when the arm is at 56 degree position. Thus, the tip of the robotic arm is closer to the base when the arm is at the 48 degree position. Okay. Okay, people struggle with this one. What they're giving you here, they're giving you a scenario here that sets up this picture, and they're telling you that this angle right here is 65. If that's 65, then this one here is 115. Okay, and if this is 60, This one here is 120. Okay, so they're going through here, so using the angles, or using the measures of the turning angles to find the measures of those two angles that I just found. Measure of what do they call it, ACD and BED. That's what we're looking, because the turning angles are supplementary to these angles. Okay, these white angles are referred to as the turning angles. Okay, it says, how does the Hinge theorem help you solve this problem? It says the Hinge theorem relates the distances of the ships from starting point with those two angles that we just found, ACD and BED. Okay, so keep going through this. It says, which ship is further from the starting point? Okay, well, because 115 is smaller than 120, across from 115, that distance should be smaller than that distance. So that distance is bigger, because the angle of 120 is bigger than 115. Okay, so they want to know which one is further. Ship B is further because the measure of angle BED is greater than the measure of angle ACD. All right, again, it's just comparing those angles of 115 and 120. So if I compare those, then I should know the sides across from them, how they equate or are unequal to one another. Perpendicular segment from a vertex of a triangle to a line containing the opposite side, that is an altitude. 29, point of concurrency of the medians of a triangle, that is the centroid, also the center of gravity. The point of concurrency of the perpendicular bisectors, that is the circumcenter. This statement is used to describe a figure constructed or drawn around the outside of another figure. Usually the vertices of the figure on the inside must touch the figure on the outside, i.e. triangle on the inside with a circle around it. The three vertices of the triangle must touch the circle. So a picture of this, they're talking about what is that shape on the outside if we have that criteria. Well, that's, scribed means to draw or to write. So it's either, where are we at here? It's either that or that. Now they're talking about the one on the outside, so that's circumscribed. Okay. 32, when three or more lines intersect at a point, that means they are concurrent. The length of the perpendicular segment from a point to a line, that is the distance. Okay, distance from a point to a line. 34, when a point is the same distance from two objects, that's equidistant. 35, the point of concurrency for the angle bisectors, that's the incenter. 36, the statement used to describe a figure that is constructed drawn on the inside. Drawn on the inside is inscribed. 37, that's a median. Vertex to a midpoint. 38, a segment connecting the midpoints of two sides of the triangle. Each triangle has three midpoints of two sides. That's a midsegment. 39, the point at which three or more lines intersect. That's the point of concurrency. I guess my review here is a little bit off from the questions that towards the end here. There are a couple questions that I cut out. This one is a duplicate of one earlier in the question, so don't worry about this one. We already seen this one. Already seen that one. And a reminder that I gave everybody this one back, so don't worry about that one as well. Okay. So as you progress through this test here towards the end, these questions, mainly 40, 41, 42, they're a little bit different than what you saw in your test because I altered your test, and I guess I didn't pay attention to which one I pulled up here to do the review, but they're identical up until that point. If you have questions about anything on here, please let me know. Remember the review or the retake will be at 7:30 on Friday.